In this lesson, we're going to be talking about our binomial factorings. As we can see here, we have two terms. Our first step, again, is always to find a greatest common factor if there is one. In this case, we do have a greatest common factor. Our greatest common factor is 3, because between 3x squared and 243, we can divide out a 3. So when we do that, we want to factor out the 3. So on the outside we'll have the 3x squared divided by 3 would just be x squared, and then 243 divided by 3 is 81. So just like with our trinomial factoring, the next step would be to try to factor the inside after we factored out a greatest common factor. So again, here we have our binomial factoring because we have two terms. I have x squared and 81. Our first option with our binomial factoring would be to see if we can use difference of two squares. So with difference of two squares, we'd be able to factor it if 1, it's a difference, meaning that there's a subtraction between the two terms. And then second, if there's two perfect squares. So if the first term is a perfect square and if the last term is a perfect square. If it is a difference of two squares, then it would be of the form a squared minus b squared, which can then factor into a plus b and a minus b. So we need to figure out if this is a difference of two squares. So first we can see that with the x squared minus 81, it is a difference because we have a subtraction between the two terms. Then we need to figure out if we have two perfect squares. Well, 81 is a perfect square because 9 squared gives you 81. And x squared is considered a perfect square as well because x quantity squared is equal to x squared. Which means that in order to apply this formula of a squared minus b squared equals a plus b, a minus b, we need to find a and b. So first, we have that a squared would be equal to our first term, x squared. Well, if a squared equals x squared, that means that a would just be equal to x. Same idea with b squared. B squared would be equal to just the 81, not negative 81, just 81. And then again, we would either want to do the square root of 81 or figure out what squared gives you 81. And we should know that 9 squared gives you 81. Once we figure out what a and b are, then we can just plug it into this formula, a plus b, a minus b. Again, it has to be a difference of two squares. If we didn't have a perfect square, then we couldn't use this formula. So on its own, then we would have the 3, that was part of our greatest common factor on the outside. Then we would have our a plus b and our a minus b. So a, again, is x, so x plus our b, which is 9, and then x minus 9. And this would be our completely factored form since we did have that greatest common factor in the beginning. What's important to note is that this doesn't work if we have a sum of two squares. So for example, if I had x squared plus 81, we cannot factor that using this formula. Also, if you did check this by FOILing it out or multiplying out, your middle term would cancel, which is the reason why we get back to that x squared minus 81. So in this example, we have another binomial that we want to try to factor. So again, first step is to see if there's a greatest common factor that we can factor out. In this case, we do not have a greatest common factor, so we can skip that step. Next, we would look at our options for our binomial factoring. We had in the first example, if it was difference of two squares, we would be able to factor it into a plus b, a minus b. Well, in this case, 125 at a minimum is not a perfect square. Also, x to the third is not a perfect square, but in terms of your numbers, 125 is not a perfect square, so we cannot use our difference of two squares. But we can still factor this. Our second option with our binomial factoring would be to use the sum or difference of cubes formula. So if a binomial is considered a sum or difference of cubes, we have two options. So first, if it is a sum of cubes, we would have a cubed plus b cubed. That would factor into a plus b times a squared minus ab plus b squared. If we had a difference of cubes, that would be of the form a cubed minus b cubed, which would factor into a minus b times a squared plus ab plus b squared. So both are kind of long, but as you can see, they're actually fairly similar. Each of your terms, a, b, a squared, ab, and b squared, are the same within both of them. Your signs is just how they change. Some people like to think of this in terms of your signs as using the acronym SOAP. SOAP standing for your first sign is the same. So if I started off with a plus, my first sign in my factored form is also going to be a plus, so same sign. Then the next one would be an opposite, so if it was a plus, the next one is opposite, that's your O. And then your AP represents always positive, so your last term's always positive. So your same, then it's opposite, then it's always positive. So that just help you to identify your signs. Same thing if you look at our difference of cubes formula, your first factor a minus b, that minus is the same as the original. The next sign would be a plus because it's the opposite, and then the last one's always positive. So some people like to use that to help. So how this is going to help us here is that x to the third minus 125 is actually a difference of cubes formula. So similar to what we had with our difference of two squares, we still want to figure out what a and b are. So that first term, a to the third, in our case, would be equal to x to the third. Well, that means that a is equal to x. B to the third is then equal to 125. Again, don't take the negative, just 125, which means that b is equal to what to the third power gives you 125? Well, that ends up just being 5. In your calculator, you can use the cube root button, which is found under math. So if you hit the math button, go down to cube root, you could do the cube root of 125, and that would also tell you that 5 to the third gives you 125. Once we identify what a and b are, then we can just plug into our appropriate formula. So since, again, we have a difference of two cubes since we have subtraction, we're going to be using that a minus b times a squared plus ab plus b squared. So when we substitute that in, our a is x, so we're going to have x minus b, which is 5, and then a squared, which is x squared, plus a times b, which would be x times 5, and then plus our b squared, which would be 5 squared. And we do want to simplify the inside of that second parenthesis, so we have x minus 5 stays, x squared is going to stay x squared, and then x times 5 is 5x, plus 5 squared gives you 25. And this is fully factored, so although we have a binomial times a trinomial, that trinomial won't be able to be factored anymore. So this is your answer. So we have one more binomial factoring. Again, our first step is to see if there's a greatest common factor, which we don't have. Our second step would be to see if we have a difference of two squares. Well, at first, I can even see the fact that we have a plus between. It definitely would not be difference of two squares because we have a plus, so that wouldn't work. Next, we would try to see if we have a sum or difference of cubes. So again, it definitely wouldn't be a difference of two cubes because we have a plus sign. So then it's a matter of determining if we have a sum of two cubes. So again, if it's that sum of two cubes, it would be of that form a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So to determine if we do have a sum of two cubes, we need to figure out a and b. So we start off with a cubed would be equal to 27x to the third. So then we need to figure out what a is. So first, with our coefficient 27, we need to figure out what to the third power gives us 27. Or again, using your calculator, you could do the cube root of 27, which that ends up just being 3. Our x to the third, as an a to the third part, means that a is just going to be 3x. All right, so the x just comes down. Then our b to the b cubed would be 1. Well, what to the third power gives you 1? That's just 1. So b cubed equals 1, and b also equals 1. So that means that we do have a sum of two cubes, and we have our a is equal to 3x, and our b is equal to 1. So we can plug into this formula, so that way we have that a plus b would be 3x plus 1. Then a squared means I'm squaring all of 3x. We have 3x quantity squared minus a times b would be 3x times 1 plus b squared would be 1 squared. And again, we do want to simplify inside the parentheses. So 3x quantity squared means this is going to become 9x squared minus 3x times 1 is 3x, and then plus 1. Again, this is your final answer. That trinomial cannot be factored anymore. So those are your three types of trinomial factoring. Always look for a greatest common factor first, difference of two squares, and then sum or difference of cubes.